The CH-47D Chinook medium-lift helicopter depends on electricity to operate. Each helicopter has hundreds of individual circuits, both AC and DC. To satisfy its voracious appetite, the aircraft contains 7 buses with 8 possible sources of power. In fact, this aircraft in flight can use as much electricity as a modern home. The electrical installation on the CH-47D is comprised of 2 similar but independent AC and DC generating systems called number 1 and number 2. Each system has the capacity to supply the electrical requirements of the aircraft. Both the AC and DC circuits are controlled from power distribution panels, or PDPs. Each of the circuits in the aircraft is protected by a circuit breaker on one of these panels. The number 1 power distribution panel is located outboard of the co-pilot's seat on the left side of the cockpit. Essentially, it services the left side of the aircraft. The number 2 power distribution panel is located outboard of the pilot's seat on the right side of the aircraft. It basically services the right side of the aircraft. Primary AC power to operate the aircraft in flight is provided by 2 Lucas 40 kVA AC brushless generators that produce 200 volt, 400 hertz, 3-phase power. These generators are mounted on and driven by the aft transmission and are cooled by oil from the aft transmission. The number 1 main generator, mounted on the left side of the transmission, provides AC power for the number 1 AC bus, which is in the number 1 PDP. The number 2 main generator is mounted on the right side of the transmission. It provides AC power for the number 2 AC bus in the number 2 PDP. The number 1 and number 2 generators are identical. They each contain a main alternator armature, shown here, and a permanent magnet generator, or PMG. These generators are the main source of power for the aircraft. When each generator is turning at 12,000 RPM, its PMG produces a 40-volt AC output that is fed to its respective generator control unit. Each GCU monitors its generator for under and over voltage, under frequency, and differential current, and also regulates the generator's output voltage. 3 circuit boards are contained within each GCU, 1 for frequency sensing and control logic, 1 for current sensing and power supply, and 1 for voltage sensing and regulation. In addition, there is an excitation control relay, a generator contactor relay, and a field output transistor. The number 1 GCU is located in the electrical compartment at the front of the left pod. The number 2 GCU is located in the right electrical compartment. The generator control units are connected through switches in the cockpit to contactor relays located in the power distribution panels. The contactors connect the generators to the number 1 and number 2 AC buses. All the individual AC circuits feed off these buses. Each AC system has the capacity to supply the complete electrical requirements for the aircraft. If one of the generators fails, the AC bus tie closes, allowing the other generator to power both buses. The 2 systems are widely separated in the aircraft to minimize losses due to battle damage. When the aircraft is on the ground, all AC power requirements can still be met by use of a 3rd generator, the Auxiliary Power Unit generator. This generator is mounted on and driven by the Auxiliary Power Unit, APU, which provides AC power for ground maintenance. The APU generator is an air-cooled 20 kVA AC brush or brushless generator. It produces 205 volts, 400 hertz, 3-phase power. The APU generator also has a permanent magnet generator. The PMG for the APU generator supplies AC and DC power as soon as the generator starts turning. It, in turn, is connected to its own GCU, which is different from the GCUs used by the main generators. This control unit has 2 plug receptacles on the front. It uses a black conversion plug to control a brush-type generator or a red conversion plug with a brushless type generator. The APU generator control unit contains 4 circuit boards. They are for under and over voltage protection, under frequency, voltage regulation, and differential current. The generator control unit for the APU generator is located in the right electrical compartment. There is a switch for it on the electrical panel, and a contactor and a slave relay in the number 2 PDP. When these relays are energized, they will connect three-phase AC to the number 1 AC bus. Power is then routed through the number 2 AC bus tie to the number 2 AC bus. If it's impossible or impractical to start the engines or the APU, you can still get AC power to the aircraft. There is an external power receptacle in front of the left electrical compartment. It is connected to the external power monitor inside the left electrical compartment. This device monitors the incoming power for proper frequency, over or under voltage, and phase sequence. If the power is acceptable and the aircraft is not receiving power from the onboard generators, the external power contactor in the number 1 PDP connects it with the number 2 AC bus. The bus tie will also connect it to the number 1 AC bus, powering the whole aircraft. If any of the onboard generators start producing power, the external AC is disconnected from the bus. Many of the instruments require 26 volts AC. Power for this purpose is provided by 2 auto-transformers, one in each PDP. The auto-transformers receive 115 volts AC and step it down to 26 volts AC. That completes the AC system, but the Chinook also needs DC power to operate. The DC power system of the CH-47D contains 5 DC buses. 4 of these buses are powered by any of 4 possible power sources. The 5th bus, the battery bus, is only powered by the battery. The CH-47D has a 19-cell, 24-volt nickel-cadmium battery. The battery is used for starting the APU and as an emergency power source in the event that all other power in the aircraft is lost. In emergency mode, the battery will not last long, just long enough for the pilot to land the aircraft safely. Thus, it is important for the battery to be kept at full charge. There is a battery charger analyzer in the left electrical compartment above the battery. A sensor cable from the battery allows the charger analyzer to monitor the battery for cell imbalance, over temperature, voltage above or below 80% of the full charge, and to provide a charging voltage to the battery. The charger analyzer receives 115 volts AC from the number 1 AC bus. It converts this AC to DC to charge the battery anytime the battery voltage falls below 80% of full charge. The charger analyzer is also connected to a warning light in the cockpit. The battery energizes the switched battery bus through a relay found in the number 1 PDP. When the battery switch is turned on, the battery is connected to the DC essential bus and is able to power 3 of the 5 DC buses. The other 2 buses, the number 1 and number 2 DC buses, receive their power from the number 1 and number 2 AC buses by way of transformer rectifiers in the electrical compartments. The transformer rectifier units, or TRUs, operate off 200 volts, 3-phase AC. The transformer in each TRU steps down the 200 volts to 48.5 volts, 3-phase AC. 6 rectifiers convert the 48.5 volts AC to 28 volts DC. Inside the TRU is a cooling fan operated by AC. An AC quick disconnect input connector is located on top of the TRU with positive and negative output terminals located underneath. The number 1 TRU, located in the left electrical compartment, powers the number 1 DC bus, the essential DC bus, and the switched battery bus. The number 2 TRU, located in the right electrical compartment, powers the number 2 DC bus and the essential DC bus. To protect and control the TRUs, reverse current cutout relays are connected to the TRUs. As soon as the voltage coming from the TRU is greater than the voltage from the battery, the reverse current cutout relay, located in the PDPs, will connect the transformer rectifiers to the DC buses. If one of the TRUs should fail for any reason, the reverse current cutout relay will disconnect it from the bus and operate the appropriate TR fail relay, which in turn will operate the DC cross-tie relay to connect the 2 DC buses. There is one other way to get DC power to the aircraft. That is by using external DC. When external 28 volts DC power is plugged into the aircraft, it energizes the DC external power relay in the number 1 PDP. connecting the external power to the number 1 DC bus and disconnecting the TRUs. This, in turn, powers all the DC buses except the battery bus. In summary, we see that the main generators power the number 1 and number 2 AC buses. These, in turn, power the 26 volts AC instrument auto transformers. The number 1 and number 2 DC buses receive their power from the AC buses by way of the transformer rectifiers. In turn, the number 1 DC bus provides power to the essential DC bus and the switched battery bus. The battery powers its own bus and in turn is charged from the number 1 AC bus. If the source to either of the DC buses should fail, there is a bus tie relay that will connect them to restore power. Similarly, if one of the generators fails, there are bus ties to connect the 2 AC buses. At 40 kVA, either generator produces enough power to operate the whole aircraft. If both generators go out, the auxiliary power unit generator can come online, connecting it to the number 1 AC bus. The APU generator is used for aircraft ground operations and aircraft startup only. If all power sources fail, the battery will still operate the aircraft for about 15 minutes. If in flight, this is long enough to set the aircraft down. On the ground, if you don't want to or can't run the auxiliary power unit, you can plug in external power. Plugging in DC will power all the DC buses. Plugging in AC will power the entire aircraft. In use, the electrical system goes from the simplest to the most complicated. The battery allows the auxiliary power unit to start, which powers up the system so that the main engines can start. When the engines get up to speed, the main generators are turned on and the APU generator is turned off. It takes a lot of electricity to operate a Chinook. It's up to the 68 Foxtrot electrician to keep the electrical systems running so that the Army can keep its Chinooks flying.